Okay, now that we've learned about our three similarity theorems, angle, angle, side, 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 and side angle, side similarities, let's apply those and see if we can determine or verify that triangles are similar. So are triangle ABC and triangle DEF similar? Just at a quick glance, I can see we are working with side lengths. We weren't given any information on the angles, so let's try to figure out, are all the sides proportional? So let's find those scale factors or the ratios of all of our corresponding sides. So one thing that's very helpful, they're asking if this triangle is similar to this triangle. So I'm going to follow kind of the order that it's written to help me pair up my corresponding sides. So AB, that side corresponds with DE. So I'm going to see what AB over DE, what does that ratio give me? So side AB, if we look at the picture, I'm just going to substitute in a 3. We can see this is a 3. Side DE is 4.5. So 3 over 4.5. If we divide that, we get a 0.6 repeating. I would say, let's reduce this fraction, but we might not see how to reduce something with a decimal. But when we divide that 0.6 repeating, hopefully we just recognize that is a 2/3. All right, our next corresponding sides, I'm just going to move on. We just did AB. Now I'm going to go to the next two vertices, BC. So let's check BC over its corresponding side, which is going to be EF. Now I can go to the picture. I can find that BC is 4. EF is 6, and 4 over 6, we can reduce that to 2/3. So it's looking good so far. We're getting the same ratios, 2/3, 2/3. Our last two sides is going to be let's see, AC from the first triangle. Its corresponding side is DF from the second triangle. So AC is 5, DF is 7.5. That does divide to a 0.6 repeating, which is 2/3. So we just found that all the ratios are the same. So when that happens, you have similar triangles. We have shown the work to prove it. So we can now say that triangle ABC is similar to triangle DEF. And how do we know? By side, side, side similarity. All right, let's look at part B. Are triangles PQS and RQP similar? Well, this one gets a little tricky because if we look at triangle PQS, PQS is the whole triangle. Is that similar to RQP? And RQP is this one inside. So I think what's going to be helpful with this example is let's draw these separate. Triangle PQS is PQS. Let's draw that triangle on its own. Here's the P, Q, and S. And we're just going to copy down our side lengths. We can see that PQ is 18. And RS is 15 and 12. So if we just add those together, we're going to get 27. So now let's take a look at the other triangle we're working with, triangle RQP. So from R to Q to P, we want this smaller triangle. So let's redraw that one. R, P, Q, or RQP. And then we can see that RQ is 12 units long and PQ is 18 units long. All right, so one thing to notice, even it's a little easier to see when they're kind of together like this, Do you see how angle Q is part of the blue triangle and it's part of the red triangle? So that means right off the bat, we know that angle Q, well, angle Q is congruent, in one triangle is congruent to angle Q in the second triangle. So we have one angle that's congruent. I don't see any other angles that we can determine are congruent to give us our angle-angle similarity. So let's go see if we can find the side angle side to work out. All right, so if we follow along with our corresponding sides here, we know that PQ and RQ will correspond. So let's see. Oh, we have PQ down here. We have RQ over here. So we're checking to see if our sides are proportional. So we're going to take PQ over RQ. And again, I'm looking at this order to help me do that. PQ are the first two vertices, RQ are the first two vertices. Those will be corresponding sides. So then I look at the picture. PQ on the left is 18 units long. RQ on the right is 12 units long. 18 doesn't divide by 12, but we can reduce that. Divide both by 6 and we get 3/2. All right, so the next pair of sides I could check is QS from one triangle and QP in the other. So if I look, oh, we do have QS, so we can use those. We're going to set QS from the first triangle over QP of the second triangle. So QS is 27 units long. QP is 18 units long. We can reduce that by dividing them both by 9, and we get 3/2. So we are getting proportional sides with that same scale factor. They have the same ratio. So we can determine that triangle PQS is similar to triangle RQP by the side angle side similarity. If we take a look at the picture, just to show you, here's that angle that is congruent. I didn't mark it in the picture, but here's your side angle side, side angle side. We just showed that our sides are proportional, the angles are congruent, so we have congruent triangles by side angle side similarity.